Well, commercial fishing is really important in Alaska, and the Bering Sea region in particular is one of the largest fisheries in the world, and it's a very productive region. However, it's undergoing, especially in the northeastern Bering Sea, it's undergoing some major changes. I am looking at juvenile salmon growth in the northeastern Bering and Chukchi seas. So I'm interested in how energy is carried up through the food web, because that ultimately determines the overall condition of fish species such as juvenile salmon. What we did today, we took sea ice cores, and we were focusing on the very bottom of the sea ice core, so the interface between the ice and the seawater, because this is where most of the biological activity is. And now they're melting in the lab, and we're going to go ahead and take a look and see what kind of critters we find. And then we also took ice cores and measured temperature, and we will do salinity measurements as well, so that we can compare the biological attributes of the core to the physical attributes of it. The extent and timing of sea ice melt is influential in the timing of the spring phytoplankton blooms, and the size and timing of the phytoplankton blooms really determines how much energy there is in the whole system. A lot of zooplankton have their life histories matched up to the timing of these spring blooms. So if the spring blooms are occurring earlier or later, there's a possible mismatch that could be occurring. I'm really interested in how bottom-up processes influence the entire ecosystem. So I'm really interested in the connectivity between organisms, and sea ice plays a really influential role in that.